So rational exponents as well as surds laws. So a rational number is basically any number that can be written in the form of a fraction where your numerator as well as your denominator are integers. Integers are actually numbers from 0 to positive numbers or from 0 to negative numbers. So it can be any negative or a positive number. That's why I said before you start with this lesson, you should have actually gone through the first video, which talks about types of numbers in mathematics. So these are the laws that we use in mathematics when it comes to surds as well as some rational exponents. So the first one, if you have r to the power n and it's equals to a, to find the value of r, you have to look for the nth root of r to the power n and look for the nth root of a, because what you do on the left side you also do on the right. So your r, it will be equals to the nth root of a. Secondly, we have this law. So a to the power negative 1 over n, it's the same as a to the power negative 1 all multiplied by 1 over n. So 1 over n, it actually indicates the nth root. So before we had this whole thing, it was actually nth root of a to the power negative 1. So for example, here's an example. If you have nth root of a, it's going to be equals to a to the power 1 multiplied by 1 over n. 1 over n, this 1 over n comes from this whole root. It's converted into 1 over n. If we have the fifth root of a, we were going to have a to the power 1 multiplied by 1 over 5. So your degree, this degree, you just put it over as a numerator, as a denominator below 1. If you have root, a root, and a here, it's going to be equals to a to the power 1 multiplied by 1 over a. So that's basically what that law means. Okay, and then we move. So a to the power negative 1 over n, it was previously a to the power minus 1 all to the power of 1 over n, which is the root. So if you take it back to its root form, you're going to have the nth root of 1 over a, or nth root of a to the power negative 1. And then the third law is that a to the power m over n, it was previously a to the power m, and it was under the root of n, the nth root. It was the nth root of a to the power m. So they have already removed the root. That's why we have this. So we need to take it back to its original form. So if we take it back to its original form, you take you take a to the power m and multiply it by 1 over n. That's why we have m on top as well as n below, which is equals to the nth root of a to the power m. If we have this, it's going to be equals to a to the power 1 multiplied by 1 over m. So we will be having a to the power 1 over m. But if we have a mth root of a to the power n, we're actually going to have a to the power n multiplied by 1 over m, which is equals to a to the power n over m. So that's how this law is actually used. So parts over of a surd, you have a degree. This small number here, it's called a degree. And this is called a radicand. The whole thing is called a radical. And this sign is called a radical sign or a root sign.